Hello, my name is Lindsay. I'm going to be your host for this evening's Expert Talk Online. I'll do a more full introduction once we've got a few more participants. We'd just like to welcome Jeff Williams, who's going to be our presenter. So, we've also got a few other security experts from the Equal Experts Network. What are you folk doing at the moment in the security domain? What kind of interesting things are happening for you all?
So I'm working on application security automation at the moment for a client of ours, trying to find a way to automate how we do application security testing through the pipeline to try and alleviate some of the bottlenecks and constraints we've got with more traditional pen testing. So we've done some really interesting work looking at or graphing out the number of deployments that we do on a, say, daily, weekly, monthly basis, and then comparing that to when penetration testing happens against those services and using that as a way to kind of communicate the insufficiency of pen testing as a sole means of doing security assurance. So that's leading to some interesting work around that sort of space. I know Dan's doing some interesting stuff as well on cryptography, so I don't know if he can chip in about his work there.
Yeah, the last 2.5 years I've been building like security controls, mainly around data security, like for a client which wants to have a solution to easily encrypt data as well, like large amount with high performance. And basically it's to kind of build kind of kind of an API which allow consumer to encrypt, decrypt, sign, verify, and other like crypto operation, like in a simple way where we kind of abstract all like the complexity around mode of operation, IV, and all of those type of things that often when you do security review, you can see that like developers do that wrong. And basically to kind of make it kind of hide away and to kind of take care as well to support things such as like key rotation and all those type of things like in a very easy way for the consumer. Yeah.
That's fantastic. I think really that's something that every company ought to do is try to, there's such a gap between the basic security controls that come with, like Java or something. You've got the Java security, the cryptography architecture, which is really complicated. In fact, somebody said their API is encrypted. But companies that want to get their developers empowered to do that kind of stuff, they can build an abstraction layer, an API for their developers to use that does all, hides all that complexity. Because most times developers don't need all the power of those APIs. They really just need to encrypt a string and put it in the database or something. They don't need all that power. And it's so easy to mess up, particularly crypto, but other things as well, like even input validation and output escaping are really complicated to get right. I headed up a project at OWASP a few years ago to build enterprise security API like that to help developers get those basic security controls in place. And it had things like authentication, access control, encryption, escaping and validation and logging, things like that to try to provide developers a much easier interface for the things that they needed to do. I really think that's the path towards better assurance. And I think what you'll find is you can make your pen tests much quicker if you use that approach. Because now instead of having to pen test the whole thing, you can just pen test, did they use the control correctly? And then you can have a separate review to see if your controls work properly. But the amount of total work is way less. So that's an easy way to simplify things in most programs.
That sounds great. Okay, we've got about 30 people with us now, so let's get started. Welcome, folks, wherever you are in the world. My name is Lindsay Pruitt. I'm a delivery lead with Equal Experts. Tonight, or this morning, wherever you are in the world, we've got our first talk in our series on security. And tonight, we're going to be exploring how to build awesome security instrumentation by approaching security from an inside-out perspective. We're really excited and really grateful for Jeff Williams to be joining us. He's the CTO of Planet Level, and he's going to be presenting this evening. Following his talk, he's going to be joined by Stuart Gunter, Dan Gartman, and Tommy Hamilton from the E Network for a fishbowl discussion. So I'll hand over to Jeff shortly. For the fishbowl, we're going to be using Zoom's Q&A function. So if questions come to mind during the talk, please pop them in to the Q&A using the Q&A widget in Zoom, and then vote on the questions that you'd most like answered during the fishbowl. And we'll be running through the questions based on the number of votes. Okay, I'll hand over to Jeff now. Over to you, Jeff.
All right, fantastic. Thank you, Lindsay. So my name is Jeff Williams. I'm the CTO and co-founder at Contrast Security, and you can reach me on Twitter or LinkedIn at Planet Level anytime. Just by way of introduction, I spent the last 25 years in software and security. I've been a developer. I spent a lot of time doing pen tests and code reviews, and I found a zillion vulnerabilities in some of the biggest companies in the world. I'm incredibly excited today to talk to you about security instrumentation and what you can do with it today. Ultimately, I believe security observability is the key to unlocking security in DevOps. And so we'll talk about how you can get started using that. So I wanted to start with a little story about a Fortune 100 company that I've been working with. Their CEO has been very public about saying that they're not running an insurance company per se, but a data and technology company. Essentially, they're saying they're a software company that happens to sell insurance. And they've been experiencing all the different challenges that people have when you're trying to do security on a large, complex enterprise. And I've listed some of those here. I'm sure some of you are experiencing some of those challenges with assuring the software that you're producing. But their CIO said something interesting. He said they've tried to automate application security using SAST and DAST, but their scans were still taking many hours, and they were producing what he called crappy results, and they weren't getting any value despite immense hours, his words, to automate security. So their CIO said that security is limiting the speed of innovation, and he complained about security being impedance and said, security is adding story points to every single thing they do. Well, that's a huge challenge as organizations continue to accelerate their software development. So I think, a lot of people talk about security in the context of, identifying risk and minimizing exposure and stopping breaches and so on. But I think it's really important to recognize that security can also be a risk to your software, transformation efforts. And frankly, that carries a lot more weight sometimes with executives. If you're trying to get a security program moving quickly, sometimes showing them that it can be done efficiently is really powerful. So let me talk about why I think AppSec is, I'll say, killing innovation. The traditional approach to application security works from the outside in, and I'll show it with this Blackboard kind of picture. So you imagine you got your developers over here, they're writing custom code, they're using libraries, and they're going to introduce vulnerabilities, whether it's known vulnerabilities in libraries or custom code vulnerabilities in the things that they're writing. They're going to introduce those flaws and they're going to send it into the pipeline. And then hopefully there's some tools in there, some pen tests along the way that discover these things. In the early stages, you might use static analysis in an IDE. It's a lot of false positives there, a lot of missed true positives that end up creating work for security experts or distraction for the development team. And so this is the feedback loop, and it's fairly expensive. And you'll notice most organizations pile up a big security backlog. I've seen organizations with tens of thousands of vulnerabilities sitting on the shelf that they're not fixing because they're not urgent, or they might be false positives or whatever. So this process is very inefficient and it slows development. When you continue that out across the life cycle, you can see it continues at every stage. If you're doing full software composition analysis scans on your libraries or full SAST on your applications, you'll generate more findings, which need experts to correlate them and deduplicate them and track them and risk rate them and so on. And so every time you do one of these steps, you're adding a bunch of expert work, which slows down the process. And ultimately, even your WAF, your web application firewall, generates a lot of false positives and more work for your operations team. And that, those need to be triaged and investigated before they're sort of ruled an attack. And ultimately, all this slows down the flow of software into production. And ultimately, that's what companies are trying to achieve. So to succeed at AppSec, we have to figure out a way of working inside the software development process without slowing it down. Been around long enough to know that we're not going to slow down that freight train if we do, people will just work around security. They'll deploy code that has vulnerabilities, they'll get exceptions, they'll start asynchronous processes that just work in a silo and never really impact the code. And so if we want to be effective, we've got to figure out a way to get into this pipeline and work at DevOps speed. So now I want to switch gears and talk about instrumentation. So this is the 9450. It's an instrumented basketball. And if you've met me, I'm pretty tall, I play a lot of basketball. This thing changed my life. This has sensors inside the ball, and as you dribble, it measures your dribble speed. When you shoot, it measures the arc of your shot. It measures makes and misses, gives you a whole bunch of drills and statistics through your phone. And I think it's really interesting. After I used it for about an hour, the 9450 told me that I'm shooting too flat, and I made a change and it helped my game. And I want you to just zoom back and think about that. With an instrumented ball, the role of the coach can change. Now, instead of spending time with each individual player and working on everything together, now the ball can run the drills, and the coach can be much more strategic about how they spend their time. So when I say instrumentation changes everything, I'm thinking about things like medicine. How do doctors interact with patients? Many of you may have started using telehealth services. Maybe you wear an Apple Watch that's going to tell you that your heart has an arrhythmia. Maybe you've got some other, like a blood sugar sensor if you've got diabetes. All these things change the relationship between doctors and patients in a way that kind of matches up with security. If we can be more strategic about how we use our security experts, which are in very high demand, we can change the way that people practice security in the field. So let's talk about how this applies to security. So security, unfortunately, it's easy to instrument software. People have been doing this for 20 years. It's incredibly popular in performance tools like New Relic and AppDynamic. People use instrumentation to measure the performance of their application, get feedback to developers very quickly, and show them exactly where the problem is so that they can go fix it. That's what we need in security. So here's how instrumentation works. This is a picture of the Java instrumentation API, but it works pretty similarly in .NET and Ruby, Python, other languages. Essentially, as the code loads from your disk into memory, there's an opportunity to add sensors to that code. So in Java, you register this transformer, and it gives you a shot at instrumenting methods that are interesting from a security perspective by adding these sensors that will just sort of snapshot what's going on in there. And then once the code gets loaded all the way into memory, now it's been instrumented, and it looks, to the JVM, it looks exactly as though you'd written those sensors in the original code itself. It just runs like normal software with these sensors in it. So anyone can do this. It's pretty powerful. And then as the application runs, those sensors will fire and give you an insane amount of telemetry into what's going on inside your application. And you can sort of tune it to what you care about. Now, today, I'm going to show you 3 things that you can do today. And I'll show you an open source toolkit you can use to write your own instrumentation without writing any code. And really, it's a very powerful platform. The only limit is your imagination into what you want to see going on inside your software. So when you think about this, I want you to imagine instrumentation is like having a helper or a friend inside the application as you're doing either your pen testing or your normal software testing. You've got a friend inside that can watch everything that's going on inside the application and give you feedback. So in this picture, you can see the developer is just using the application normally. Maybe inside the application, there's a query that's not protected against SQL injection. Or maybe there's an XML document that gets parsed with doc type processing turned on, which is related to an XXE vulnerability. Maybe on the back end, there's a URL going out to the back end that's got user data in it. Anything you want to see, you can tell your friend to look for it, and they can find it and give you feedback on that instantly. And so this is where the role of the security expert changes to me. Security expert can focus on hard, interesting things. Like we talked about building controls at the beginning of the talk. That's a great use of security expertise. They can focus on security architecture and threat modeling and threat intelligence, all the stuff that kind of gets pushed off because most of our security expertise is spent analyzing, output from legacy tools like static tools and, chasing the next cross-site scripting vulnerability. It's not effective. So let's take a look at how this works. So I hate to put code up on the screen because I know you're not all developers, but I just wanted to show you how easy it is to create one of these agents. This is the entire code for an agent that will detect unsafe queries to the database, queries that might be susceptible to SQL injection. So in this example, it just says instrument this Java SQL statement.execute query method or .execute method. Those are the methods we're interested in. And then when those methods run, we're just, this security advice here is just going to log a message that says, hey, you're using unparameterized SQL. It'll show us the query and it'll actually print the stack trace for us so we know exactly where that happened. And when we run this, all you'd have to do is, use this, tell the JVM, I'm doing a Java example, but it works the same in other languages. Here, we just tell the JVM to use our little agent, this unsafe SQL jar, and the application will do exactly what we said. It'll print this warning. Here's the query, and this query is not parameterized. So that means this 10,000 was user data, and we get the full stack trace. So we know exactly where to go replace that with a parameterized query and make it safe. So I want you to imagine how this can change your development process. Imagine a developer is just sitting there doing their normal job. They're just writing code and testing it as they write it. They'll get instant feedback on security right from in their own environment without having to run any scan, without having to get any pen test involved. They get feedback that they can use to replace this with a parameterized query that'll be much more secure. And in fact, if it's automated testing, now their automated test cases will fail. They'll fail their local build and they won't check that code in. They'll fix it and then they'll check in clean code when it goes into source code management. So this is a way of shifting very far left using instrumentation. So the next, I'm going to do a couple live demos here. I'm going to use a library called Jot. I released this recently to try to make the process of actually instrumenting stuff free and open for everybody without doing any coding. So the Java observability toolkit is actually not security specific. It's designed for any kind of instrumentation you want to do on your applications. With a very small YAML file that I call a Jot, you can define where you want to put the sensors, what data you want to gather, and what kind of reports you want to see out of your application. And you could gather anything. If you want to see what parameters are being sent in on various pages, you could gather that. If you want to see where encryption is used in your application, you could easily gather that. You can do just about anything. And I'm going to show you some really powerful examples, but I want you to think in the background, you can do this incredibly easily. All you need is a method that you're interested in and a few minutes, and you can have great observability.
Hey Jeff, you said you didn't mind interruptions. Can I just add a quick question there? So I guess maybe on the minds of some people, myself included, in terms of the developer, whoever they may be, do they have to have up front a whole preconceived idea of the things that they want to find? And the next question to that would be, well, what if they don't actually know what they don't know? And how do you overcome that?
Sure. So that's a great question. And it's always been a problem. That's why logging is so ineffective, because people don't know what they want to log for when they write the application, right? It's later when it's in production and you've got some problem that you want to understand, and you're like, oh man, I wish we were logging that. And then they've got to go back and add log statements, recompile, retest, redeploy to get the logging out of the application. It can take days just to diagnose a problem. So with the job observability toolkit, you can quickly, without any programming, you can add this kind of data extraction to an application to make things inside the application observable. So we hope to cut down the feedback loop for gathering the information you need to diagnose a problem. And then the other thing, it's directly to your question, yeah, developers don't know everything they want to look for, particularly in security. And so one of the aspects of this JOT project is to try to get people to contribute their JOTs. If you come up with a great JOT for detecting XXE vulnerabilities or performance problems or whatever, you can contribute them, and we'll build a library of those things here. There's already several dozen JOTs available in the project, but we'll build a whole community of them, so you could quickly grab one, add it to your application, and get a new chart or a new feed of information out.
Yeah, makes sense. Yeah. Cheers.
Yep. So let's take a look. I'll do this JOT first, and I'll just demo it. The slides are here in case you ever want to do this yourself, but I'll just demonstrate it live. So we're going to use this application called Ticketbook, which is an open source application with a bunch of vulnerabilities in it. And you can see there's sort of normal functions available. So what we're going to do is I'm going to kill this and add a JOT to this. So the first thing is, let's look at the JOT. So we're going to look at rules, and we're going to look at the SQL one. This is a whole JOT. It says we want to capture the route. That's sort of the public entry point for this. When you use the application, this will be like the URL. We want to capture any unsafe queries. So this says capture statement.execute, execute query, and so on. We're going to exclude prepared statement because typically those are not vulnerable to SQL injection. And they're a subset of statements. So, it extends that class. So we exclude it. And we're going to capture args, which is really the query. And then for our report, we're going to plot routes and unsafe queries, so we can see exactly the route and all the queries associated with it. So that's it. Now to enable this, we just tell Java that we're going to use this JOT library. We add the standard Java agent flag, and we're just going to tell it to use that file that we just looked at to define the JOT. Then you run the application normally. So that's it to enable this. I'll just run this the normal way. And you can see as this starts up, you can see, let's scroll past. Right here, you can see there's some instrumentation going on as the observability toolkit instruments the app and installs it. And then the application just runs normally. So I'll browse here. I'm going to go to this. I'll put in equal experts. It doesn't matter. This is untrusted data that now went into the application. And when we look back at what JOT captured here, you can see this table that we built that shows the method call, the route, and the unsafe query. And so this last one that was sent here was this query select star from tickets, where the ticket equals equal experts. And so we know that there's an unsafe query. And in fact, in Ticketbook, there's a method called unsafe query or query unsafe. And that's where this unsafe query actually lives. So we know that's where we'd go in the database class to go fix that problem. So if you ran this, I just want you to imagine, add this to your applications, run them for a day or two, and then you can go back to this and you'll have a list of all the places you've used unsafe queries in your applications. And if your policy is that you should use parameterized queries everywhere, then you can quickly go fix those. So it's a powerful way of working. Let's take a look at a little more sophisticated example. So let's say we're interested in access control. Now, access control is a really difficult thing to test. I spent many years doing access control testing, and it's tricky. You got to spend a lot of time. You got to log in with each user in each role, browse around the application, figure out what you can access, then go to another role and see if you can access the stuff from the first role. And it gets, the combinatorics gets really complicated. If there's a dozen roles and 200 endpoints, it gets very complicated to figure out if you've tested everything. So using a jot, you can quickly do that. So I'll look at rules access.jot here, and pretty similar. We're going to capture the route. In this case, we're going to capture what user is currently logged in. We're going to capture any role checks. So in this case, this is a standard Java is user and role test, and we'll capture the parameter to that method. So that's usually that's the role name that's being requested in the code. And then we're going to produce a test coverage matrix, and we're going to produce an access control matrix. And we'll do that all automatically. So I'm just going to run this the normal way. And we'll instrument the app. And then we'll just go use the application normally. So here, I'm going to pull this over so you can see how this works. As we're browsing this application, we're going to be gathering this data. So just when I click on pages here, those sensors that we inserted with that jot, they're firing. And they're saying, hey, we're capturing a bunch of routes in the application, and we're building this test coverage matrix, because I'm still just logged in as guest. So I'm going to hit these pages that are these access pages, because they have access control tests in them. And I'm just clicking on each one time. And you can see here, I've built this access control matrix automatically. I can see on page A, we tested for role A. Page B, we tested for role B. Page C, role C. Page D, which I clicked on, you can see it's in the test matrix here, doesn't appear to have any access control checks in it. That's a little weird. Maybe there should be a check there that's missing. And then page E has 3 different access control checks, which is sometimes valid, but oftentimes it just represents some kind of strange situation that probably shouldn't be. But I want you to imagine using this on a big application and browsing around, building an access control matrix, and then just being able to look at it and say, wow, why does this, this page under /admin not have a test to see if you're currently logged in as admin? So this is, again, this is one of the hardest things to test in application security. A lot of people would call this unautomatable. They'd say it's a business logic test. You can't automate that. But it can be automated, and we can do it with a very simple jot using instrumentation. So I think this is really powerful, and almost anybody in the business should be able to look at this access control matrix and say, wow, this is not right. We can also switch users here. I'll switch to user A and click on these links, and you can see how I'm building out this test matrix over here. I'll switch to user B and just click on A, user C, A, user D, click on A, and user E, I'll click on a few of these. And you can quickly see that I've got some gaps in my testing, right? So I think it's really powerful to be able to test the application with a bunch of different users in a bunch of different roles to make sure that you've thoroughly covered all the ways of using your application. This is something that most test suites and most security tools just don't do. But even if you're using some kind of scanner, you could add the jot to the application and measure how much of the application the scanner actually found. So anyway, just a couple of kind of access related techniques that you can do with instrumentation. So I'm going to show one last demonstration of the power of instrumentation, and I'm going to do an expression language injection vulnerability. So expression language injection is a really powerful, dangerous vulnerability and attack. It's the kind of flaw that Equifax struggled with a couple of years ago. And essentially, it happens when an application accepts an expression and evaluates that expression on the server side. They shouldn't ever really do this, but for a variety of reasons, some pages do. And in the Equifax case, there was a header that came in that when processed, if it generated an error, the error page would actually evaluate any expressions that were in that data. And so just through a complicated chain of events, that expression got evaluated. So in this page, we've got an expression that we can evaluate. And if I put in 1,000, you can see the expressions being evaluated down here. And I can do more complicated things like the typical attack on an expression looks something like runtime.get runtime.exec. And here we could just do something like open-a calculator. This is just to sort of prove that I can run code on the server through the web interface. So this is a complete host takeover that I proved by opening this calculator. I could do anything I want. I could steal any files. I could run a server on there. I could backdoor it. I could start mining Bitcoin, whatever. So how do we fix this? Well, let's look at a jot that we can use to do that. So I'm going to cat another jot. We'll do rules/eli.jot. And this jot, it captures the routes just like the other jots. That's really just for reporting purposes. This is the important thing. We're going to sandbox expression evaluation in Java. So what this says is if you're inside the scope of value expression.getValue, that's what actually evaluates the expression, then we're not going to allow any calls to process builder or socket. So you can't create any native processes. You can't start any sockets. You could add other harmful things that you don't want to happen, like file access and things like that here. And we're going to throw an exception if one of these methods gets called while you're inside this scope. And we're just going to say, hey, you're attempting to escape the sandbox prevented by this, this rule that we put in place. And then we'll just keep a log of when we do that. So I'm going to run this. First, I'm going to add this jot. And by the way, you can add multiple jots. You can add a whole directory full of jots to an application at once. So it's not, you don't have to run these individually. You can add a whole bunch. I'll do eli.jot, and then we'll just run. So now we're running same application, but now we've got this protection in place. And we'll go back to this. I'm going to put in, I'm going to go to this page without the attack in it first. And you can see we can still evaluate expressions here because we're not trying anything harmful. So our application will still work. But if we try something harmful, like if I put in that same attack again, that's when this jot will intervene. And you can see, I'll zoom in, you can see this said, hey, you're trying to evaluate an expression and it's prevented by this, this jot that we put in place. So this is really powerful technique for protecting applications against attacks. If any of the companies that have been exploited by expression language injection had this jot in place, they'd be safe now. And over the last few years, there have been dozens of these expression language injection flaws in struts and Spring and other libraries. So it's a powerful technique. And again, it's not just Java. Jot is currently just Java related, but the idea here is you can use instrumentation in any environment. Okay, so I'll skip the slides, slides for each of these. So I just want to spend a couple of minutes and talk about what this looks like from the product perspective. So there's the techniques that we're talking about here fall into two categories of tools that you can get. So the first is called IAST, or Interactive Application Security Testing. And IAST just means using instrumentation to detect vulnerabilities. We just did that with the SQL sensor that we used and the access control sensor that we used. You use this in development, and it works really just like having your friend inside the application, watching it as you do your normal process, detects vulnerabilities, reports them to you with all the details, and then you can fix them and check in clean code. So that's IAST. RASP is Runtime Application Self-Protection, and it just means using instrumentation to detect attacks in production and prevent them from being exploited. And we just did that with expression language injection. You can instrument your application to make sure that your application doesn't get exploited. And these are in pretty wide use. There's, at Contrast, we sell products that do this. We've got hundreds of thousands of applications using this. There are other vendors that sell IAST and RASP. They've been on the market for about 6 years. now. And some of the advantages are that they're much more accurate than SAST and DAST, static and dynamic testing. They're much more accurate than WAFs, and they work farther left in the process. Like, as I was pointing out at the beginning, it's kind of difficult to integrate legacy security products into a modern development pipeline. So the advantage really comes from being inside the running application. When you work from the inside, you have all the context to be super accurate. So you have all the code, you have the HTTP request, you've got the libraries and frameworks and how they're used, you've got the configuration, you've got the back-end connections. All that information allows you to make really smart decisions about whether something's a real vulnerability or not. And so that's why it's more accurate. And because it's more accurate, you can go straight to development with the findings without having to go through a central security team. And that will empower them to fix their own vulnerabilities, check in clean code, and optimize the pipeline. So this is my, my caricature of that. So in modern security, when we use instrumentation, we've instrumented in IAST, software composition analysis, and RASP right into the application. We measure the application directly, so we're much more accurate. We're getting an instant feedback loop on development, so that allows you to go really fast developing. And we also get the visibility into attacks. And we've got a number of customers that have said, if you're clean in Contrast, so you've identified your vulnerabilities, you've got your libraries straightened out, so you're not using libraries with known vulnerabilities, and you've got RASP in place, so you're protecting in production, then you're cleared to go into development, into production at whatever velocity you want to go, because you can automate so much of the process here. That's a real carrot for development teams to adopt this technology and push applications into production faster. And so ultimately that's, that's a way of doing security that's compatible with modern software development. And really that's what DevSecOps is all about, is shifting left, integrating security and development in a way that developers and security folks can work together instead of just fighting all the time. And I like to finish with this slide. It shows the mean time to remediate vulnerabilities using SAST and IAST. So when we look at SAST, you can see, and this is results from a major vendor's annual report, and they show that they fixed 29% in 30 days, 4 months to fix half the problems, and 71% by the end of the year, which I don't think is nearly good enough. That's a lot of window of exposure, if you will. So using IAST, we've seen on average, companies are closing 50% of the vulnerabilities in 7 days, and by a month, they've closed 61%, and you can get to 90% by the end of the year. If we look at customers that have used IAST for a while, worked off some of their backlog, we're seeing them get to 75 or higher percent closed vulnerabilities in about a week, and 95% by the end of the year. That's, to me, that's the essence of shifting left. If you have an organization that thinks they're shifting left, this is kind of what they should measure. It's how fast they're remediating, because that's what kind of optimizes the life cycle. And I'm optimistic about application security. I don't think that any one technology is going to fix our security issues. I think good security requires the right mix of people, process, culture, technology. But I do think that security instrumentation can create a platform where development and security can work together. And I think that's really the key to unlocking high-speed innovation in companies. I wanted to do a quick plug for Contrast Community Edition. It's totally free and full-strength application security platform. You can use it on a single app, and for totally free. But it's got all the features of our commercial product. It does RASP, so it protects you against attacks. It does IAST, so you can identify your vulnerabilities, and it does software composition analysis, so it'll analyze all your open source code for vulnerabilities. And it's a powerful way to to try this stuff out. If you're a small company with only one app, then you're in good shape. You can use Contrast Community Edition today to secure your application layer. So with that, I'll stop and pause, and please, if you have any questions, we're going to have a fishbowl. Please submit your questions, and I'd love to take them.
Great, thanks for that sort of interesting talk, Jeff. Before we go into the fishbowl, we'll just do a brief introduction to the other people on the panel. So whilst we're doing that, please, if you've got questions, use the Q&A widget to put questions in. If you cannot put them into the chat, because that's not visible to everyone on the call. So if you've got questions, put them into the Q&A widget. So I'll hand over to Daniel. Do you want to introduce yourself, and then Stuart, and then Tommy?
Yeah, hi, I'm Daniel Gathman. I'm a security engineer, as well part of the security practice at EqualExpert. And my two main area of expertise is web security and cryptography engineering. That's me.
I am Stuart Gunter. I'm a security practice lead at EqualExperts, and I work with a variety of our clients on a bunch of security related challenges, usually around the space of how we integrate application security and infrastructure security testing within continuous delivery. So looking at how we can reduce friction, making sure that we still meet those security requirements and still be able to demonstrate security in what we're producing without constraining the flow of value, as Jeff illustrated in his talk.
Hi, I'm Tommy Hamilton, and there's nothing worse than being last because you have to say, same as those guys. Security consultant and architect, and happy to be here. Thanks.
Great. Okay. Thanks very much. So we've got 6 questions in the Q&A. We'll just take them from the top at the moment. So the first one was from one of the panel put in before the talk. So Instrumentation is great for back-end applications, but there's a growing variety of mobile apps, single-page web apps, and also IoT apps. So what does the future of security instrumentation look like for apps that are running on customer devices?
Yeah, so I fully believe that the future of software, for any kind of software, is that it'll be instrumented for security. It just doesn't make sense not to. I mean, everything that's complicated in this world, we instrument it. Cars and planes and space shuttles and factories, they've got all kinds of sensors. And you'd be crazy to run a modern factory without a ton of sensors, because it allows you to identify problems early. So some of the mobile and IoT platforms don't have great support for instrumentation yet, but I'm 100% convinced that they will, because they kind of have to. I think probably the important takeaway for today is that in those applications, they all connect to server-side APIs. And most of the security risk is in those APIs on the server side. That's where all the data for all the customers is stored and where most of the risk is. So instrumentation works great on those APIs. It's kind of irrelevant whether that code's running in containers or cloud, or if there's Elastic, whatever, it doesn't matter. You can set up your instrumentation to just run as part of the application. So it goes wherever the code goes.
Great, thanks, Jeff. Anyone else want to chip on that before we move on to the next question? Okay, right, so next cover a question from Abdul. Does the Java implementation use aspect-oriented programming and bytecode manipulation? I just want a bit more detail about what the friend is actually doing, how it works.
Yeah, it's similar. I'd say AOP is the right idea here. It kind of died out in popularity, I don't know, a number of years ago, but it's essentially that same concept. Is we're using something like point cuts to weave in sensors into applications to gather data. The JOT library just makes it really easy to do that work. I guess AOP requires a little more programming than I think is really effective for most development teams. So yeah, it's the same concept.
There was actually an OWASP project, I can't remember the name of it right now, which is based on this sort of premise, but it allowed similar sort of flexibility in defining what those rules are. I'll see if I can find.
AppSensor, right?
Yes, AppSensor, that's right, yeah. So you might be able to find more details on that if you wanted to see another example, a similar concept applied perhaps in a slightly different way, but also using AOP.
Great, thanks. That's a good amount of detail there. Okay, and the next question we had is about the performance header of using RASP. So, and also a bit more detail on how you'd add RASP to it. Is it difficulty adding it to legacy applications, maybe those written in C#?
Yeah, so on the performance side, the instrumentation, all it really does is adding code into your application. I think it's generally safest to just add a single static method call into, to shove that into the method that you're interested in gathering data from. So that has very low overhead. It's really what you do inside the sensor that matters. The sensors that I showed you are insanely fast. They don't do anything expensive. They really just record a little bit of data and then return. So I've tried to measure it. It's really, almost difficult to measure. It's like between 10 and 20 microseconds on a round trip request. It's insanely fast. So, that's not to say you couldn't write sensors that were more expensive. If you do a bunch of regexes and, a bunch of logic and, maybe you try to write the data to a database or something, it could get quite expensive, but we're super sensitive to performance. So, I think you can write this instrumentation in a way that's really fast.
How much of that is pre-packaged, Jeff? It sort of semi-relates to the conversation earlier, but when watching your presentation, the bit that I really liked was the bit about logical access control and the whole role stuff. That is always a nightmare. And seeing it so beautifully presented that way, I mean, anyone could look at that and understand that. And that is a really difficult thing to do. And I know that as a consequence of doing a presentation, you pre-package stuff. So it's very Blue Peter, here's what I made earlier. But in terms of a developer coming along for the first time, what's the learning curve to get to that stage? Because it looks like clearly there are some prepackaged things that you've already got, these jots that are already defined. But what does that couple with that makes the whole thing work collectively?
Yeah, I mean, the goal of the jot project was to make instrumentation easy enough that anybody could do it, or any developer could do it. And so, you can see here that whole jot for access control is just this. It's a couple of sensors. I mean, if you just wanted just the access control piece and not the user, the test coverage matrix, you could actually get rid of this and this and just leave this access control matrix piece. And it just compares routes against roles. Like, I think this is a really straightforward way of defining that. So, I think the learning curve is pretty low, but frankly, this is a really early days for this project. So,
and is this very much tied to Java at the moment? Obviously, the stuff you're showing now is
I think
using Java primitives, and if you venture off the beaten track, are you going to then lose some of the capabilities?
I don't think there's nothing in this that's tied to anything specific in Java. Like, this would work on any Java application. In fact, it would work on client-side Java, and probably on IoT stuff written in Java. It's just really what you want to use it for. Like, if you're looking for encryption algorithms and use of MD5 and stuff like that, you could use this on anything today. It'd be trivial to find. And there's a jot in the jot package to do that already. But like I said, it's pretty early. I imagine that this YAML language could be replicated for other programming languages. Like, you could do something very similar for, say, .NET, or I think C# was mentioned a second ago. There's nothing that prevents someone from building something like jot for C#, and I hope maybe somebody will join the project and build a jot.net.
Yeah, maybe back to what you said with MD5. In the past, I wrote just like a POC to see how can you detect which kind of crypto function or crypto primitive is being used. And I used as well ByteBuddy, and I saw that you were as well using ByteBuddy in the demo, but I was wondering, is the jot project as well based on ByteBuddy, which makes and as well like Contrast. So is the Contrast product based on ByteBuddy? I'm wondering whether it was like good enough, or are you using like the lower level API, which makes it very, very hard? I mean, much more complicated than using ByteBuddy? Because I found ByteBuddy, I think everyone who spends half a day can write instrumentation by themselves, but I was wondering how are you doing that at Contrast?
So I think probably, you know, well, ByteBuddy is fantastic, and this is based on ByteBuddy for sure, which is a great library, and you know, we know the guy that that built it. Contrast, you know, we use our own instrumentation for performance reasons because ByteBuddy isn't super optimized for performance. But I think my take is that even though ByteBuddy is pretty easy, you've got to be a pretty senior developer to be able to get your head around it quickly. I don't see the vast majority of developers being able to get their head around instrumentation and build useful stuff that way. There's just too much in the way. So Jot is designed to kind of bridge that gap and let anybody create really, you know, pretty powerful expressions. You can see actually for this sensor, you can see this is actually a Spring expression. So the captures, the things that pull the data out are actually expressions. You can do some really powerful stuff in those to gather data. So we're trying to provide a ton of power with very simple language. So that's where we're trying to fall, and we'll see if it works.
Thanks, folks. Shall we move on to another question?
Yeah.
There's two quite related ones. So John Stavley asked, how does this type of solution compare with putting something like Cloudflare in front of your web application? And there was a follow-up about Fastly's recent purchase of Signal Sciences. What are your thoughts on that? And there was another question about what your view is on how to use WAF if you're running this kind of instrumentation.
Yeah, great questions. So look, WAF has been around for 20 years almost, and hasn't really evolved. I was going to try to make an analogy, like WAF is like covering your house in saran wrap, and you know, instrumentation is like building security sensors all over your house so you can detect anything in any room, anywhere. So I think the problem with WAF is really that application protocols have gotten so much more complicated. You know, modern applications, if you look at an HTTP request, it's all JSON, it's all XML, it's serialized objects, it's WebSocket with God knows what data going back and forth. And I can look at that traffic and not be able to tell whether it's an attack or not, because it's really tricky. And so it makes it really hard for automation to do that. And so it's just always going to have a ton of false positives and a ton of false negatives. Meaning it'll overblock and underblock. So that's not a good place to be. That means you've got still attack vectors open, and you're getting a ton of noise that you have to go deal with. So things like Cloudflare are good at, the really simple stuff. They'll take the noise away, the obvious scans from burp and zap and things like that. They'll identify that data and take it off the top. That's great. But if you really want to protect your application against things like XXE and SSRF and unsafe deserialization, you need something like RASP. How's a WAF going to stop an unsafe deserialization attack? All it sees is a serialized object. It can't deserialize it in the WAF and figure out what it is. Only the application can deserialize it because it knows what's in there. So, I just don't see how WAFs protect against sort of modern attacks very well these days. I think it's totally fair to use both, like Cloud WAF with default rules that just do a decent job of taking away the noise, and then RASP to actually protect your applications against the attacks that matter. That seems like a good combination to me.
Could I just echo that, Jeff? I've seen that so many times, and I think what makes that worse is the WAF tends to get pushed out to that edge where you were articulating beautifully before, where you end up with a whole load of reports that overwhelm people. They don't really understand it. And all they have to do is go back, speak back to the people who do know. And there's a time delay and a whole load of red tape that gets you there. When from this perspective, information is getting to the people who will understand it the quickest. So they can digest that, understand that, and there's no intermediaries, no proxies, human proxies, all the way to that point. And and to lay the last nail in the coffin for that one, it tends to be 9 times out of 10 they'll pay for the gold service that you can pay for, because they tend to be large organizations. And what they'll do is they'll be scared to turn the thing on for real, so they'll turn it on in reporting mode only. And where does that get you? So yeah, I totally echo what you said.
I think I can add a real world example to where I think WAFs really struggle. And the key problem is that they lack the context that you would get from running inside the application. So you can get a WAF to do some amazing stuff if you're prepared to invest a huge amount of time teaching it about the application. But I just don't see why you would do that. So I've worked on an engagement where we have a WAF sitting in, or had a WAF sitting in front of an application, and we had a user that was blocked because their last name was curl, spelled like the command line utility. And so the WAF blocked that user from using the site, from logging into the site, because all it did was it saw the word curl and it said, you can't come in because you look like an attack, which is about as primitive a check as you could possibly make, borderline on lazy. Whereas if you're in the application, you can say, well, that word curl isn't being used to try and invoke a command line utility in the operating system. Exactly. So why should we block this user from accessing the site and potentially buying a product, using the service, whatever it might be? So for me, the key difference is a WAF almost always lacks context. I've yet to see anyone actually invest the time to teach it about the application. But the other thing that I think was really useful is if you remember from the demonstration, those, at least until the RASP scenario was being played out, those weren't attacks that you were doing. That was just a regular search, but it was telling you where the application was vulnerable. A WAF is the opposite. It won't tell you where you're vulnerable until you're attacked. And by definition, it can only tell you what it knows about. So the combination of the context and being able to tell you before you've actually got an attack launched against your site is where the real value comes in for me. So WAF is great as a sort of a security blanket, an extra layer of security, but I don't personally feel comfortable with that as the sole coverage for the application.
Yeah, I can share a stat. We protect tens of thousands of applications in production, and 98% of those attacks are what we call probes. They never connect to the corresponding vulnerability, right? So we'll see a command injection attack never gets near a command invocation. SQL injection attack never gets near a database query. In your curl example, I suspect that you're exactly right. That data, it probably gets, when he's trying to log in, it probably comes in and goes to a database query or something and never gets near the command line. But the WAF has to flag it because it doesn't know what it's protecting.
Okay, great. Thanks for covering that. Right, shall we move on to another question then? So Raspen, I asked the really kind of useful approaches. As I was watching you demonstrate both those, I was wondering whether they take much tuning, because I can imagine that you probably might get false positives when you're using them. So what's your experience of tuning these things?
Yeah, it's a fair question. IAST requires dramatically less tuning than, say, static or dynamic tools. Because IAST has all the context from inside the app, it doesn't tend to make the same kinds of mistakes. So you should see a dramatic improvement in accuracy. That doesn't mean that it's perfect. I mean, the kind of tuning that we see the most is sometimes you have to tell the IAST about a security control that's in place. Like IAST reports a SQL injection because it saw data flow from the source to the sink, but there may be an escaper in that path that IAST didn't know about, didn't put a sensor in, and so it doesn't see it. In contrast, we deal with that problem by we actually analyze the application for potential security controls. So we look for things that look like validators and escapers and encryptors and things like that. And then we don't want to automatically approve those because we don't know if they're good or not, but we'll show them to you and say, hey, which ones of these are the controls you want to rely on? And just let you go tick, tick, tick and choose those. But that's the kind of tailoring that's required. You can look at, if you're interested, you can look at the OWASP benchmark, and you can see, I think this is a really good project, because what it does is it actually tests these tools to see where they have problems with true positives and where they have problems with false positives. So they built like 2,700 test cases, and you can see how different tools fare against that test suite. But as you'd expect, DAS tools are accurate. Like this is IBM's dynamic tool. They're accurate, but they miss a lot. And static tools tend to find a lot more false positives, to the point of being kind of absurd. And then, in the middle is a bunch of vendors who've tried to compromise on that. But really what they need to be doing is moving up and to the left, because you want to be 0 false positives and all the true positives. So, and that's where, Contrast aces this test. So we finish in 30 seconds, and we found, all the vulnerabilities with very low false positives. Actually, we would have got a perfect score, except we disagree with them about the test case. Like, I actually think the path traversal test case is broken, but I don't want to be misleading. This doesn't mean that Contrast never has a false positive. What it means is Contrast can ace an easy test. And if you look at the other tools, I think what you'll see is very true to reality. If you look at, like, say, Fortify, for instance, you can see they've obviously optimized for finding everything without regard for false positives. So if you look at some of the harder things like path traversal and SQL injection, kind of the data flow ones, you can see they're all over here at the right, and they've got a tremendous false positive rate. So, that I frankly think if you're finding everything and flagging all the false positives, you're not really providing much value. That's why the benchmark measures value as like, how far are you from this random guess line?
That's a great resource.
If you're buying tools, I think this is a great resource, because it'll really help you understand. You can see, look at, Veracode, for instance, and you can see exactly where they're good. They don't do anything for XPath injection. So that's just,
okay.
That's
great.
Yeah.
Thanks for showing that. Cool.
Yep.
Okay. Right, we're going to have to wrap up there because we don't want to take up too much more of people's time. Thank you kind of very much for all the questions from people. A special thanks to Jeff Williams from Contrast Security for his really interesting presentation. I particularly found seeing what you can do now with that type of instrumentation quite impressive. And then thanks to Stuart, Tommy, and Daniel from the network for participating in the panel. If you'd like to kind of see a recording of this talk or share a recording, then it'll be posted on the Equal Experts YouTube channel and our website in the next few days. Next week in our security series, we're going to be exploring the OWASP Top 10, which is the industry guide for the biggest security issues facing web applications. We're going to have Robert Hamilton, an Equal Experts tech lead in South Africa. He's going to be taking us through what the OWASP Top 10 are and how to practically exploit and defend them, and why most are relevant beyond just web applications to anything you're building today. If you'd like to sign up for that talk, then you can do so over at equalexperts.com. So thanks again to Jeff Williams. It was a really fascinating evening, and thanks for people's questions and the discussion. Okay, I hope the rest of your days go well. Thanks, bye.
Yeah. Cheers, guys. Thanks, Jeff.
Thanks, bye-bye.
Bye.